In this video, we're going to read about minerals and rocks. Minerals and rocks of which planet? It's about Earth. The Earth is composed of various kinds of elements. If you look at the figure, you can see top elements and their percentages. Apart from these elements, there are other elements as well, like hydrogen, phosphorus, manganese, sulfur, carbon, nickel, but they are found in less percentage. Now, what is the difference between minerals and rocks? First of all, you must know that minerals are found in rocks, and these rocks are found in Earth's crust. But then a rock has more than one type of mineral. That's why we need to extract them. We cannot simply take a piece of rock and say, hey, I've got so and so mineral. Mineral has one specific chemical composition, whereas a rock is a collection of different minerals. Just remember this. Now, it is a known fact that Earth's lithosphere, that is the crust and upper mantle, consists of limited elements. That's why if you look at the periodic table, you'll find only these many elements. They're about 118 to 120, something like that. So the point is, we have limited elements. Now these limited elements combines in many different ways to form variety of minerals. Let me give you an example. You have heard of this mineral called magnetite, right? It is one of the oxides of iron. And if you look at its chemical formula, it's Fe3O4, meaning it has iron and oxygen elements in certain ratio. So this is what I meant when I said elements are limited, but these limited elements combines in different ways to form minerals. So far we have around 2000 minerals that are known and identified in the earth crust. Now the main question is, what is the source of all these minerals? Well, for that we have to go to the interior of the earth's surface, where the hot magma exists. When the hot magma comes out of the surface, it cools and then solidifies. As a result, it turns into rocks with crystals of minerals on it. And like this, series of minerals are formed as the rock cools down further and further. Now let's quickly understand the physical characteristics of minerals. Minerals have been divided under these categories, so we will quickly go through each one of them. Now if you look at minerals close enough, all you will see is these tiny bits and pieces of crystals. So talking about physical characteristics of minerals, we are going to refer to these tiny bits of crystals. The first one is external crystal form. By this we mean external shape of an individual crystal, and what looks outside is a direct reason behind how it is formed inside. We know everything is made up of atoms, and a group of atoms bonded together is called molecule. Therefore, the internal arrangement of molecules of a crystal is the reason behind the external look of a crystal. The internal arrangement of molecules could be in the form of cubes, octahedrons, hexagonal prisms, etc. The second one is cleavage. When a crystal breaks, it happens due to fracturing or by cleaving. There will be a split along a smooth plane, and it occurs because of the structural weakness, meaning the internal molecular arrangement of that particular area of the crystal is weak, and that causes a crack. The third property is fracture. Now, fracture and cleaving is almost same, but the only difference is cleaving happens at a plane area of a crystal and fracture takes place in a non-plane area. Cleaving is a fine crack that is a smooth and almost a perfect crack, but a fracture is not a smooth one. It is rough and not uniform. Again, fracture also happens because of the structural weakness, meaning the internal molecular arrangement of that particular area of the crystal is weak, and that causes a crack. The fourth one is luster. The meaning of the word luster is shine, bright, or polished. Each mineral has a different luster. Some are metallic, silky, then glossy, etc. It totally depends on the color of mineral. Because of the color, light is reflected from a mineral's external surface, and that's what makes it sparkle. The fifth one is color. So how do we as human perceive color? How do we know it's blue, red, yellow, green, brown, black color? When different wavelengths of visible light falls on our eyes, that's how we see different colors. Now when light falls upon crystal of a mineral, some wavelengths are absorbed by the atoms of the crystal, while others are reflected. Those ones which are reflected from the mineral's surface, when they enter our eyes, that's how we perceive the color of a mineral. Now, depending upon the molecular structure of the mineral's crystals, wavelengths of light is reflected accordingly, and that's how we find the color of a mineral to be white, green, red, yellow. The sixth one is streak. Now, streak is the color of a mineral substance when it has been grounded to a fine powder. So two minerals that have similar color on the outside may have different colors when they are powdered. For example, Hematite and galena. We can easily get confused when we look at their color. It's gray color. However, hematite streak is blood red, while galena streak is lead gray. The seventh property of a mineral is transparency. When a light ray passes through an object, it is called transparent. But if the light ray gets diffused, that is called translucent. And if the light ray does not pass at all through an object, it is called opaque. Therefore, some minerals are transparent while others are opaque or translucent. The degree of transparency usually depends on the thickness of the mineral. The eighth one is structure. Mineral crystals occur in various shapes and sizes. Again, we have read this. The structural shape and size of a mineral crystal is due to the internal arrangement of molecules, meaning how they are joined. And this is called the crystal lattice. The ninth property is hardness. Now, hardness is one of the better properties of minerals to use for identifying a mineral. Hardness is a measure of the mineral's resistance to scratching. The Mohs scale is a set of 10 minerals whose hardness is known. The softest mineral is talc, which has a Mohs scale rating of 1. Diamond is the hardest mineral and has a rating of 10. Softer minerals can be scratched by harder minerals because the forces that holds the crystals together are weaker and can be broken by harder minerals. The last property is specific gravity. Now, specific gravity of a mineral is a comparison or ratio of the weight of the mineral to the weight of an equal volume of water. The weight of the equal volume of water is found by finding the difference between the weight of the mineral in air and the weight of the mineral in water. So these were some of the physical properties of a mineral. And I think I should have told you in the beginning as to why we need to know them. So let me just quickly answer that. The reason we need to know the physical properties or characteristics of a mineral is because when we study a particular mineral, we can use them to make products we use in our day-to-day life. Everything around us contains minerals, from buildings to roads, then food to water, everything has minerals. So that's why we need to study them. Minerals are of two types. They are metallic and non-metallic minerals. Now we're going to read about metallic minerals. Of course, by the name we can figure out that these are minerals that contain metal, and they are also subdivided into three types. They are, the first one is precious metals, like gold, silver, platinum. I don't need to tell you why they are called precious metals. The second one is ferrous metals. The letter Fe in ferrous is the IUPAC name for iron. So ferrous metals have iron content. That's all you have to remember. The third one is non-ferrous metals. Now these metals do not have any iron content. They include metals like copper, lead, zinc, tin, aluminium, etc. So these were the metallic minerals. Now let's look at the non-metallic minerals. Now these minerals do not contain metal content. Of course, if it is opposite of metallic, then they will not have metals. Now some of the examples of non-metallic minerals are sulfur, phosphate, and nitrate. And cement is a fine example of non-metallic mineral. Now we're going to talk about the second important topic in this chapter, that is rocks. This chapter is about minerals and rocks, and we are done with the minerals part. Now it is about rocks. Now if you have seen my video, that is different layers of earth, you will find the link in the description. In that, if you have known anything, that would be this simple fact that our earth consists of rocks. It is through rocks that we have known whatever that is we know about our earth. Now earlier in this chapter, we have read how minerals are found in rocks. Therefore, it is also reasonable to say that rocks consist of minerals. Rocks are hard as well as soft, and they are also of different color. But one important aspect that you must remember is that a rock does not have one single mineral content. It has a combination of different minerals. Feldspar and quartz are the most common minerals found in rocks. Now, quartz is found in igneous, sedimentary, and metamorphic rocks, while feldspar is found only in granite. By the way, petrology is the study of rocks. They study about mineral composition, texture, structure, origin, occurrence, alteration, and relationship with other rocks. Now, if you become a geographer, you'll need a basic understanding of rocks, because that's how you will get to know the landform and probably the Earth's surface. So rocks are categorized under three families on the basis of the mode of formation. They are igneous rocks, sedimentary rocks, and metamorphic rocks. Let's understand each one of them. So the first one is igneous rock. Now igneous rocks are formed out of magma and lava from the interior of the Earth. So magma is also called molten rock, and it is found in the mantle of the Earth. If you remember this pic showing the different layers of Earth, mantle is filled with magma, and when magma comes out of the surface, it cools down and becomes solid. That's how the igneous rocks are born. Now, igneous rock is also known as primary rock because it is formed from magma, so anything that is formed right from the core ingredient of the earth has to be called as primary rock. The word igneous is derived from a Latin word called ignis, which means fire. Now, mantle is filled with magma, and when magma comes out of the surface, it cools down and becomes solid. That's how igneous rocks are formed. So, mantle is in a way a fire. The process of cooling and solidification can happen both in the Earth's crust as well as on the surface of the Earth. We now know that igneous rock is formed from cooling down of magma. But you need to understand this. When magma comes out of the mantle, it can sometimes just stay under the crust. It need not get out on the surface. Sometimes magma just cools down under the crust itself. That's why during open cast mining, large chunks of igneous rocks are found. Igneous rocks are classified based on texture. When we say texture, we mean something like this. Look at the color as well as design pattern. And this texture depends upon size and arrangement of grains or other physical conditions of the materials. So if you remember while reading about physical properties of minerals, there we read that the external shape depends upon the molecular arrangement of crystals within. So rocks are these tiny soil debris packed together. And depending upon these debris, the color of the grains, overall external look will be dependent on it. If molten material is cooled slowly at greater depths, mineral grains may be very large. Sudden cooling at the surface results in small and smooth grains. Remember the third point where I said sometimes the magma cools down under the crust itself and does not really comes out on the surface. So when magma cools under the crust, it does become solid, but it does not get exposed to the external weathering agents like wind, river and ice. Because of that, the mineral grains do not break, they are intact. And as it is, there is a huge amount of pressure under the crust, and plus temperature is not normal too. So in this situation, those igneous rocks that are formed under the crust or in deep depth of the earth, they tend to be very large in size. It's like as long as the rock is under the earth's surface, the pressure and temperature doesn't let the mineral debris to split apart. It keeps them intact. The intermediate conditions of cooling would result in intermediate sizes of grains making up igneous rocks. When you look at the rocks that comes under igneous rock, I'm talking about granite, gabbro, pegmatite, basalt, volcanic breccia. All these looks different in terms of texture and composition. And it is because of the fact that all these rocks have evolved with different conditions. I mean, some cooled early, some late, some faced more pressure, some faced less, conditions like that. After all, two products will look different only if there is a change in their process of formation. How else can they be different then? So this was about the igneous rocks. Now we move on to the second type, sedimentary rocks. The word sedimentary is derived from the Latin word sedimentum, which means settling. First of all, sedimentary rocks can be easily broken down into tiny sediments of mud and soil debris. They also have the tendency to settle down in the Earth's surface easily. Rocks of the Earth's surface are exposed to denudational agents and are broken up into various sizes of fragments. These denudational agents are also referred to as exogenous forces like wind, water, ice, etc. These forces over the time erodes the rock and breaks it down into small soil debris. It happens to all types of rocks, that is igneous, sedimentary and metamorphic. Such fragments are transported by different exogenous agencies and deposited. These deposits through compaction turn into rocks. This process is called lithification. Now this process is also known as the rock cycle. I've made a video on it, do check it out. Nature has such nice way of performing this rock cycle. Rocks are eroded with the help of exogenous forces like wind, air, ice into tiny little soil debris. These debris, they move from one place to another again with the help of the same exogenous forces. Now these small fragments gets deposited in the form of layers and layers one after another. This process creates pressure that is called compaction, and as it is there is good amount of heat under the crust, so it becomes all the more easier for these debris to develop into a full-fledged rock. This process is called lithification. In many sedimentary rocks, the layer of deposits retain their characteristics even after lithification. Hence we see a number of layers of varying thickness in sedimentary rocks like sandstone, shale, etc. So if you look at shale and sandstone, here it is, notice there are line patterns depicting layers. So these are the layers of deposits. They are very much visible. It is not visible in every sedimentary rock. Now, depending upon the mode of formation, sedimentary rocks are classified into three major groups. The first one is mechanically formed. When we say mechanical, that means it follows a natural pattern. How rocks weather down, then becomes tiny soil debris, which later on with accumulation and compaction becomes a rock again. So this is a natural cycle, also known as mechanical cycle. Now, when we say organically formed, we mean rocks formed from organic debris such as leaves, roots, and other plant or animal material. You see, limestone and coal contains fossils, and that's why they are organically formed. And when we say chemically formed, we mean rocks formed due to precipitation of minerals from water. Precipitation is the creation of a solid from a solution. If you see, how is halite, potash, and limestone formed? Millions of years ago, evaporation of seawater led to the formation of these minerals. So this was all about the sedimentary rocks. Now we go to the last division of rock called metamorphic rock. The word metamorphic means change of form. Just like metamorphosis, where a caterpillar transforms into butterfly, so the word meta means change in other form. Now these rocks from under the action of pressure, volume and temperature changes. Rocks are as it is so hard, and to change their form, just imagine how much of pressure and temperature is required. So it needs incredible amount of pressure and temperature. So in the previous point I said metamorphic rocks require great amount of pressure and temperature. The question is where and how will the rocks get the pressure and temperature? So you see, the tectonic movement is referred to as the movement of plates on which oceans and continents reside. When two plates come closer, we call it as convergent boundary. In convergent mechanism, a smaller plate subducts under a larger plate. With this, all the rocks that is sedimentary and igneous moves towards the mantle, that is under the crust. That's how pressure and heat influences the rocks to become metamorphic. Metamorphism is a process by which already consolidated rocks undergo recrystallization and reorganization of materials within original rocks. So this recrystallization and reorganization of a rock happens due to extreme heat and pressure. When the rocks make their way inside the mantle during subduction, heat and pressure acts on them and transform them into metamorphic rocks. Now the transformation of metamorphic rocks happen in two ways. One is through dynamic metamorphism and the other is through thermal metamorphism. Let me cover these 2 points together. Now rocks undergo dynamic as well as thermal change. So one is due to pressure of the massive weight of the landform and the other is due to heat from the interior of the earth. It is very easy to remember this. In chemistry, if you want to separate the elements from a mineral, you basically heat it to a point that it melts. So thermal metamorphism does chemical alteration to the rocks. Now under thermal metamorphism, they are of two types. One is contact metamorphism and the other is regional metamorphism. To understand this, I'll do an illustration. So far we know that rocks make it to the interior of the earth due to tectonic activities, right? Now when the rocks are under the crust, the contact metamorphism refers to the point where these rocks come in direct contact with hot magma and lava. So this is going to melt the rocks and recrystallize them in different form. So this is contact metamorphism. Now in regional metamorphism, the rocks do not become molten rocks in order to change their shape. They just need the incredible pressure of the landform above and high temperature as well, but do not mistake it with molten form. It need not melt the rock. That's why contact means in touch with magma and regional means around the magma, so that heat of the magma does the trick. In the process of metamorphism in some rocks, grains or minerals get arranged in layers or lines. Such an arrangement of minerals or grains in metamorphic rocks is called foliation or lineation. Now have a look at this picture. You see this horizontal line, nice clear pattern sort of a thing? This is called foliation or lineation. Imagine how much of pressure this rock must have gone through so that layers are visible. Now in the similar manner we have banding, where layers appear in light and dark shades. They will not have a clear pattern, but still you will see different layers of shades. That's why this is also called as foliation. Now types of metamorphic rocks depend upon original rocks that were subjected to metamorphism. Metamorphic rocks are classified into two groups, foliated rocks and non-foliated rocks. We have read about what are foliated rocks. So under foliated rocks you will see a nice clear pattern sort of a thing, and then you have a banded rock. But the non-foliated rocks looks like this. you'll see random patches of shades. Basically, it looks like an ugly rough rock. But you will not at all find any layer. That's how you can recognize foliated and non-foliated metamorphic rock. Now we are going to read about the last topic of this chapter, rock cycle. I'll quickly wrap up this topic with a simple illustration so that you can understand this topic better. Now this is the picture of a rock cycle. So no rock remains the same. With time, pressure and other natural forces, they transform. Remember we called igneous rocks as primary rocks, and the reason is because they are directly formed from the magma and lava when these molten material solidifies. So anything that is formed from the basic most ingredient of earth has to be termed as primary rocks. Now that we know igneous rocks are called primary rocks, ultimately the other rocks, that is the sedimentary and metamorphic rocks, are called as secondary because they are formed from igneous rocks. Let me explain how. You see, igneous rocks are the reason sedimentary and metamorphic rock exist. Let's see it as a story. Imagine the magma coming out of the mantle through volcanic eruption. Now this magma cools down and becomes solid crystal, and that is how igneous rocks are formed. Now as time passes, various weathering agents, or we can also call them exogenous forces like wind, rain, glacier activities, acts on this igneous rocks, and they slowly turn into, or rather I would say break rocks into these small fragments or debris which we call as sediments. And then these small fragments or debris are buried under layers and layers. With time and pressure they cement together into sedimentary rocks, and this process is called lithification. I have a video on sedimentary rocks, the link is in the description. In that I have explained how a sedimentary rock breaks into smaller chunks or debris, and when you see those debris you can easily relate what I'm talking about. So that was the formation of sedimentary rocks from igneous rocks. Now this sedimentary rock has the tendency to break apart again into smaller debris or sediments. Now comes the part where we need to find out how metamorphic rocks are formed. Do you remember that caterpillar changes into butterfly? We call that process as metamorphosis. So this metamorphosis occurs in rocks as well, especially when they are heated to 300 to 700 degrees Celsius. Now where does the heat come from? Now inside the earth there is tremendous amount of heat due to pressure. Push your hands together very hard and you can feel the heat. Rub them and due to friction you will have heat. Similarly, when Earth's tectonic plate move around, it produces heat. When the plates converges, meaning comes closer, they build mountains. Now that is also a tremendous amount of pressure and heat. Now that we know how the heat comes from, what does this heat do to the rocks? It bakes them. Just like how you bake a cookie from dough, it does not melt the dough, right? It changes its form. Similarly, rocks do not melt, it transforms into metamorphic rocks. That's why you'll find metamorphic rocks mostly in mountain areas. And again, with exogenous forces like wind, water, these metamorphic rocks can be broken and washed away into sediments, and these sediments can again make sedimentary rocks. The rock cycle never stops. Metamorphic and igneous rocks find their way into the mantle through subduction. It happens when two plates converges, and then one plate goes under another. This way all these metamorphic and igneous rocks find their way into the mantle. And we know mantle consists of molten rocks called magma, and again magma comes out on the surface through volcanic activity, and that's how you find the sources of igneous rocks. So this is the rock cycle. I hope you understood with this illustration. With this we have come to an end of this chapter. I hope you found this video informative. So thanks for watching, and I'll see you in the next one. If you want to see more of such educational content, make sure you're subscribed. By doing so, you'll get an alert when my next video comes. Thanks for watching, and I'll see you in the next one.